the hollow cylinder. Everyone, draw the hollow cylinder. Sachin, draw the hollow cylinder. Huh? You already did. Very good. Okay. So this is how you draw the hollow cylinder. Okay. The inner radius of a pipe is 2.1 centimeter. So yesterday, if you have listened to me very carefully, I have used the word inner circle, outer circle. Inner radius, outer radius. Am I right? Huh? And you all know what is it. So children, they are talking about inner radius. So can't I say small letter r is equal to 2.1 centimeters? Yes, small letter r is 2.1 centimeter. Right, Sandra? How much water can 12 meter of this pipe hold? So they are telling you if the length or the height of this pipe is 12 meters, then how much water this pipe can hold? Let's understand this question. The inner radius is 2.1. Okay, fine. They have told you that the length or, children, they have used the word how much water can 12 meter of this pipe hold. Nowhere they have mentioned the word height or length, isn't it? Nowhere they have used these two terms. But it is a matter of common sense to understand they are talking about the length of the pipe, isn't it? So like when the pipe is lying on the floor, you use the word length. But at the same time, when you lift the pipe and keep it straight or perpendicular to the ground surface, the length can also be called as height. Are you getting it? When it is lying on the horizontal surface, you call it as the length of the pipe. At the same time, you lift the pipe and keep it perpendicular to the ground, then it becomes height. All right. So I have drawn the pipe in such a way that it is standing perpendicular to the ground surface. So I can say the height of this pipe is what? 12 meters. Now they are asking us to find how much water. You remember the last thing which I taught you yesterday. The last thing which I taught you yesterday, what was it? The capacity of a hollow cylinder, isn't it? And when I taught you capacity of a hollow cylinder, I used a very particular a term. It is the inner volume, isn't it? Children, always remember when you have to find the quantity, when you have to find the capacity of a hollow cylinder, it is equivalent to the inner volume of the hollow cylinder. Please remember this because you contain or you carry water inside the hollow cylinder, right? So if you find inner volume, that is equivalent to the quantity of water which the pipe can contain. Quantity of water which it can contain is the capacity of the container or the pipe. All right. So what is the formula? Sachin, what is the formula to find the inner volume of a hollow cylinder? Pi small r, repeat, pi r square h, isn't it? Now you know the value of r and h, but if you substitute the values over here, I'm telling you, you're going to get the wrong answer. Can somebody tell me why did I say so? Exactly. Here the radius is what? 2.1 centimeters. Here the height is what? 12 meters. So if you have two different units, you shouldn't be doing the calculation. You will get a wrong answer. You should always make sure that you're using the quantities with the same unit. So the radius is centimeter. You can convert height also in centimeter. All right. 1 meter is equal to how many centimeters? 100 centimeters. So 12 into 100 centimeter. Otherwise, 1200 centimeters. Okay. You got the radius and the height. Yeah, you can. So radius square is what? 2.1 into 2.1 multiplied by the height is how much? 1200. Okay. 1200. perform the calculation and then give me the answer. If you need help, look here. 7 1. Salim, can you see from there? Okay. 7 ones are and 7 into 0.3. So you get 22 into 0.3 into 2.1 into 1200. Okay. As Arthur said, instead of writing 1200, you just leave it as 12 into 100. That will help you in doing calculations. See this? It is 12 into 100. Okay. 0.3 into 2.1. How much it is? It is 0.63, right? 0.3 into 2.1 is 0.63 into 12 into 100. Now, very easily you can remove that decimal point. How? Because 0.63 when multiplied with 100 will give you how much? 63. So 22 into 63 into 12. If you do the calculation, you will get the quantity of water which the pipe can fill. Do it fast and send me the answer. Amal and Janice has got 16632. I think it is 16632. Yeah. How many of you got? 16632. Very good. Very good, children. 16632 centimeter cube. Aditya, did you find the answer? Very good. Maria, Anika.
No, sir, I'm doing it. I joined kind of late.
Okay, fine. Very good, Gopika. I hope there is no doubt in this. Fine. Let's move on to the next sum. Question number 2. Salim, you copied it, the previous one? A cylinder of circumference 8 centimeter and length 21 centimeter rolls without sliding for 4.5 seconds at the rate of 9 complete round per second. Find the distance traveled by the cylinder in 4.5 seconds. Okay. Now don't try to do this. I'll explain. There is a cylinder of circumference 8 centimeter and length 21 centimeter. So this part is what? Giving you the information about the dimensions, isn't it? Circumference 2 pi r is equal to 8 and the length or the height is equal to 21. So we will utilize that later on. But first of all, let us understand what is happening in this question. They are talking about, the cylinder rolling without sliding, isn't it? So we first need to understand what is happening with that cylinder. Then we will use the dimensions to get the required variables, right? So it rolls without sliding. Now, what is the meaning of rolls without sliding? Imagine, children, this is the cylinder, okay? This is the cylinder. Now, when I say the cylinder is rolling without sliding, imagine the cylinder was placed over here. So at point A, somebody pushed this cylinder from back. So what will happen? The cylinder will start rolling, isn't it? It will start rolling, and after a while, the cylinder will reach over here. The cylinder will reach over here. Okay. Imagine this is your point B. This is your point B. So what's happening here, children? Let us understand it clearly. There is a cylinder which is kept on the ground surface. Okay. The cylinder is touching the ground surface at point A. Somebody is pushing the cylinder from the back. So what happens? The cylinder starts rolling without sliding. Sliding in the sense, slipping. You must have seen, children, at times when you are riding your bicycle or your bike, suddenly if you apply brakes, the wheel will stop moving, but your bike will be still moving. What is that movement called? Sliding, isn't it? At times, a lot of You must have heard people saying that, my bike skid, isn't it? My bike got skid because of heavy rain and I fell down. There are so many accidents happening because of that. You must have heard of it. So what happens, you are going at a very high speed. Suddenly you applied the brake. Okay, the wheel movement stopped, but the bike couldn't stop. Why? Because of that force. You must be learning in physics also. Because of the force, the bike couldn't stop and the wheel skid on the road and you fell down. It happens many a times, children, especially during the rainy season. Okay, so that is the meaning of skidding or sliding, where the wheel is not rotating, but it is just slipping on the ground surface. So here when they say the cylinder has to roll without sliding, it means the cylinder has to roll without slipping on the ground surface. That means from point A to point B. From point A to point B, whatever is the distance covered by the cylinder, it has to be covered by rolling on the ground surface. Rolling on the ground surface. Understood? Fine. If that part is clear, let me ask you something. Children, imagine this is the cylinder. Okay, this is the aerial view. This is the aerial view of the cylinder. And imagine it started moving from this. It started moving from this point. Okay, point A. And it has to reach this point B. It has to reach this point B. If I ask you, what would be the area covered by this cylinder while moving from point A to point B? Can somebody answer this question? Yep. Curve surface area? You tell me any one thing. Tell me. Circumference. From this point till this point, only circumference is enough? Jaren? Curve surface area into? Okay. RPM. We are not learning physics. Anybody else online? Circumference. Did I deny that? Everyone is saying circumference. All right. I'll ask you something. Into number of? Perfect. Rotation? Okay, fine. Anyways, I'm not very familiar with that. All right. Online students, what do you opine about this? If you want to find the area covered by the cylinder from point A till point B, how can you find the total area? Children, do the curved surface area multiplied by the number of times it has rolled, isn't it? Children, let's take a very simple example for that. Imagine, it's okay, children. If you're not able to answer, it's okay. Imagine this is the wheel of your cycle. Okay, this is the wheel of your cycle. Now, the wheel of the cycle has touched point A on the ground. I'm telling you that this wheel can cover. This wheel can. Pavesh. He's in his native. He's in his native. So, okay. Let's understand the situation also. Yeah. Yeah. Now listen. Over. Now listen. Children, imagine this circle is the wheel of your, this circle is the wheel of your cycle. And it has to start traveling, okay? It has to start rolling on the road. I am telling you that the radius of this wheel is equal to 7 centimeters. Just assume, okay? The radius of this wheel is equal to 7 centimeters. Can you tell me in one rotation, how much would be the distance covered by this wheel? Imagine you are riding a cycle. In one rotation, how much would be the distance covered by the wheel? How much it would be? Huh? You gave me one definite answer. 14? Okay. Amal is saying 14. You all are saying 14? All right. Now, children, I asked you how much would be the distance covered by this wheel in one rotation. So when I use the word one rotation, children, don't you feel this is the distance which you have to find? Huh? Because, Arey, you listen to me. You listen to me. Don't interrupt in between. This is the distance which you have to cover in one rotation because the wheel of your bicycle, when it is traveling on the road, which portion of the wheel is touching the road? The circumference of the wheel, isn't it? How do we find the circumference of a wheel? It's a formula 2 pi r, isn't it? The circumference of the wheel is what? 2 pi r. Children, I'm talking about circumference, not the area. Okay? The wheel is rotating on the ground surface. So when the wheel is rotating on the ground surface, the circumference of the wheel is touching the ground. Do you all agree with that? Joanne, is it clear? The circumference of the wheel is touching the road, isn't it? So I told you what is the radius of the wheel. It is equal to 7 centimeters. It is equal to 7 centimeters. So if I ask you, in one rotation, how much is the distance covered by the wheel? How will you get the distance? The distance will be equal to the circumference of the wheel, which is 2 pi r. So how will you get the answer? 2 into 22 by 7 into the radius is what? 7. 7 and 7 will get cancelled. 2 into 22 is what? 44 centimeters. Now try to understand what I said. Children, this wheel is going to start its movement from point A. This wheel is going to start its movement from point A. So when this wheel rotates one time, the distance covered will be how much? 44 centimeters. That means from point A till point B, how much is the distance covered? It is 44 centimeters. So after one rotation, your wheel will be found over here, touching point B on the ground surface. Is this part clear? Huh? In one rotation, the distance covered by the wheel is 44 centimeters. Now, is it clear? Fine. Online students, is it clear? In one rotation, the distance covered by the wheel is 44 centimeters. Now, let me upgrade this question. As of now, it was regarding a wheel, isn't it? Now let's convert, or let's try to understand the scenario in which you are having a cylinder to roll on the ground surface. A cylinder to roll on the ground surface. Children, so imagine this is the cylinder which we are talking about. This is the cylinder which we are talking about. All right. Now, let's take the length of this cylinder as, say, for example, 14 centimeters. And then the radius of the cylinder as, say, for example, 7 centimeters. Okay, 7 centimeters. And I'm telling you that the cylinder is going to roll on the ground surface. The cylinder is going to roll on the ground surface. I will ask you one question. Think over it and then answer, okay? The radius is how much? 7 centimeter. My question is, from this point A, if it starts traveling in one rotation, how much would be the distance covered by the cylinder? How much would be the distance covered by the cylinder? 44. Do you all agree with it? The distance covered will be the same, which is 2 pi r. That is equal to 2 into 22 by 7 into 7. That is equal to 44 centimeters. So you're wondering, Arey, the same answer you got for a bicycle tire. Now you are getting the same answer for a cylinder also. How come it is possible? Children, it is possible because I never changed the variable which you had to find. Be it a cycle's wheel or a cylinder. I am just asking you to find the distance covered by it in one rotation, isn't it? So be it a cycle wheel or a cylinder, you just need to focus on what? The circumference of its circle, isn't it? Because the circumference will decide how much is the distance covered by it. Do you all agree with that? The circumference will decide how much is the distance covered by the wheel or a cylinder. So no matter even if it is a wheel or a cylinder, if I ask you how much is the distance covered by it in one rotation, you will just find 2 pi r. Okay, you will just find 2 pi r. Is that clear, Jarin, Joanne? Concept is clear? Online students, everyone, this side, did you understand? Loga, repeat what I said. Just a minute, huh? Repeat what I said. Huh. Huh. What if it is a cylinder? The same thing. Very good. This part is clear, no doubt. Now, children, I'm going to slightly change the question. Okay. So what I have given here for the cylinder, the radius is 7 and the length of the cylinder is 14 centimeter. A while ago, I told you, when do we use the word length? When the cylinder is lying on the surface. And when do we use the word height? When the cylinder is standing vertical to the ground surface, isn't it? So here I am using the variable L, length. That means the cylinder is lying on the ground surface, isn't it? My question here is, pay attention. My question here is, the cylinder has started moving. The cylinder has started moving. Okay. And it has reached some point. I'm telling you that the cylinder underwent one complete rotation. Listen to this. The cylinder underwent one complete rotation. In that case, how much would be the surface area covered by this cylinder? How much would be the surface area covered by the cylinder? Get me the answer. Don't explain anything, just give me the answer. Once you give me the answer, I'll ask you how you did it. How much? Okay. Anybody else online? Okay, Caitlin. Okay, Amal, very good. 566. Did you do the calculation in the book? You got 566. Okay, Sachin. Anika is saying 566. How much? 616? 616. How many of you say 616? Okay, many are there. Milan, Alvin. 616? All right. All right, all right. It's okay, children. It's okay. At least you found some value. No, I'm happy with that. Rian is saying 616. Okay. 616. Okay, Sean. 616. Jeevan. 616. Jan is also 616. All right. Now pay attention. Pay attention. I asked you how much was the surface area covered by the cylinder in one rotation, isn't it? Children, how can you find the surface area? Which portion of the cylinder is touching the ground surface? Is the top or the base or the curved surface area is touching? The curved surface area, isn't it? So if I'm asking you how much is the area covered by the cylinder in one rotation, you should just find out how much is the curved surface area of the cylinder, isn't it? Children, it started from here, isn't it? Now it is going to rotate like this. So when it is rotating on the ground surface, which part of its body is touching the ground? It's curved surface area, isn't it? So from this point, it started rolling and then it reached over here. So its curved surface area was touching the ground surface throughout that one rotation, isn't it? So whenever you have to find the area, covered in one rotation, it should be equal to its curved surface area. And what is the formula, Anuki? 2 pi RH, which is equal to 2 into 22 by 7 into 14, isn't it? 14. 7 and 7 get cancelled. So you get 2 into 22 into 14. How much it should be? 616 centimeters square. Understood? If you have understood this logic, no, now you can easily solve the sum. Okay? Arthur, any doubt? Huh. Huh.
If the area of the rectangle,
huh.
if you already know what this is,
yeah, that we will apply in this sum. As of now, I just taught you the difference between the distance covered by a wheel and a cylinder, isn't it? Then I suddenly taught you what is the surface area covered by a cylinder in one rotation. I wanted you to understand the difference of these two. Now you read this question again, you will get an idea of solving this. Read it, children. A cylinder of circumference and length. So what I'll do is, on top of the question itself, I will mark the data. So cylinder of circumference, that means 2 pi r is equal to what? 8. Can I say this? And the length, L is equal to what? 21. Why it is length? Because it is lying on the ground surface. Okay. Without sliding for 4.5 seconds at the rate of 9 complete round per second. Find the distance traveled by the cylinder in these 4.5 seconds. Very simple it is, children. Can I erase the rest of the things? You all must have understood, no? This part? Okay. I'll take a separate page, children. Wait a minute. Yeah, let's do it here. Circumference, that means 2 pi r is equal to 8. Length, L is equal to 21. Okay. It is rolling without sliding for 4.5 seconds at the rate of 9 complete round per second. Children, you have to find the distance, isn't it? You have to find the distance. So how will you find the distance? Be it a wheel or a cylinder, the distance is always what? The circumference of the cylinder or the wheel, isn't it? So if you want to find the distance, it has to be 2 pi r. Now children, they are telling you 2 pi r is equal to 8 centimeters. All right. So can we find how much is the radius of the circle? Otherwise, see, 2 pi r is equal to what? 8 centimeter, right? They have already given it to you. 2 pi r is equal to 8 centimeter. What does this mean? The distance covered in one rotation. Do you all agree with this? The distance covered in one rotation. Just now we learned, no? If you want to find the distance covered in one rotation, it is equivalent to the circumference of the wheel or the circumference of the cylinder. That was directly given to you, 8 centimeters in one rotation. Children, did you notice this? At the rate of 9 complete round, that means 9 complete rotation in 1 second. So in one rotation, if the distance covered is 8 centimeter, then in 9 rotations, what would be the distance covered? In 9 rotations, the distance covered is equal to 9 times 8, and that is equal to 72 centimeters. Got it? Now, they have told you 9 complete rounds per second. That means in 1 second, that means this is 1 second. In this 1 second, 9 times it is getting rotated. So in those 9 rounds, what is the distance covered? 72 centimeters. Now, what is the total time for which it rotated? 4.5, isn't it? 4.5 means 4.5 seconds. Yes. So children, in 4.5 seconds, what is the distance covered? So 72 centimeter was the distance covered in 1 second. So in 4.5 seconds, it would be 72 into 4.5. How much would be the answer? 324. Sure. 324 centimeters. How many of you are getting this? 324. Jovan got it. 324. Maria got it. I'll tell you. There was the second part to this question, finding the area. Children, the second part of this question is find the area. Find the area covered by the cylinder. Covered by the cylinder in 4.5 seconds. Let me see how many of you can do this. Did you all follow what we did right now? We just found the distance covered by the cylinder in 4.5 seconds. Albina, is it clear? Sia? I am asking you how much is the area covered by the cylinder in 4.5 seconds. Think and answer. Silent. Be silent for a while. Yeah, get me the answer. A while ago, I taught you the difference between finding the distance covered and finding the area covered. Isn't it? When I told you about the distance covered, what was the formula? Monish? 2 pi r. 2 pi r. And what is the formula to find the area covered? Loka? 2 pi RH, isn't it? So you all can do it. Done? Amal, Caitlin, you all have given me the answer for the previous one. $6804. All right. How much will be the area covered in 4.5 seconds? The parameters are the same. In 1 second, 9 rounds. Total time taken to cover the distance is 4.5 seconds. Everything is same. Just that you have to find the area covered, not the distance traveled. Caitlin, I don't think so. Okay, yes, ready? Jeevan, what is the answer? 528. Okay. How much was the radius? Oh, you're finding the radius now? Why you have to find the radius, man? 2 pi r is given, no? Okay. Where is Purva? Purva is not there. Okay, Afnan. All right, now listen to this. Yes, Caitlin. 2 pi RH. Now pay attention, everyone. Huh? Okay, fine. So let's solve the sum. I'll teach you a very easy way to solve this sum. In school, they did not do this. Okay, pay attention, children. Now the cylinder started moving from point A and it reached to point B, isn't it? In 4.5 seconds. You only said the distance covered is equal to what? 324 centimeters. Do you all agree with that? From point A to point B, the distance covered by the cylinder was how much? 324 centimeters. Now I am asking you to find what is the area covered by the cylinder in these 4.5 seconds. So don't you feel this is going to be the area covered, the area which I'm highlighting in black color? Right, children? This is the area covered by the cylinder. Children, what shape I have drawn here in black color? It is a rectangle, isn't it? If you are asked to find the area of a rectangle, which two dimensions you need? The length and the breadth. For this rectangle, is the length available for you? It is available for you, isn't it? Is the breadth available for you? The breadth is also available in the form of the length of the cylinder. How much it was? It is 21 centimeters. Agreed, children? Here, the length of the cylinder becomes the breadth of the rectangle. The imaginary rectangle. So if I ask you how much is the area covered by the cylinder from point A to point B, it would be 324 multiplied by 21. And whatever is the product of these two numbers, that much centimeter square is your answer. 6,000 something? 6804. Children, were you able to visualize it? I asked you to find the area covered by the cylinder with the same parameters. In 1 second, 9 rotations. And for total 4.5 seconds, it was traveling, isn't it? So for the same parameters, you had already found the distance covered by the cylinder. How much it was? 324 centimeter. So the total distance, that becomes the length covered by the cylinder, isn't it? Now, the area which is covered by the cylinder, when you draw it on the paper, it looks like you have drawn a rectangle, isn't it? And if I ask you to find the area of that rectangular portion, you know how to find the area. It is length into breadth. The length is already found, the distance covered by the cylinder, 324 centimeters. And what would be the breadth? Breadth is equal to the length of the cylinder. So you multiply 324 with 21, you get the answer. Was that easy to understand? Online students, did you all follow it? Shall I ask you one related question to this? Okay, yeah, do this. Children, I'm giving you a cylinder. Okay, I'm giving you a cylinder whose radius is equal to 21 centimeter, height is equal to 35 centimeters. Radius and height is given to you. I want you to find what is the distance covered by the cylinder. The distance covered by the cylinder if distance covered by the cylinder when the total number of rotations are 4 in 1 second. In 1 second, the number of rotations is 4, and the total time taken is equal to 6 seconds. Okay. You have to find the distance covered by the cylinder when in 1 second it carries 4 rotation and the total time for which it rotated was 6 seconds. Am I clear with the question? In 1 second, the number of rotations is 4. That means 1 second. 1, 2, 3, 4. So similar to that, how many seconds it is traveling? For 6 seconds it is traveling. So you just figure out in 1 second, if it is 4 rotation, in 6 seconds, how many rotations it can take. 6 into 4, 24, right? Yeah. Now you get me the distance covered. Get me the distance covered. Done? All right. So can I get the answer now? How much? 3168. Okay. Online, how many of you got the same answer? Type it in the chat. Don't get disheartened if you don't get the answers, children. Okay. We need to spend a lot of time in mensuration. Got it? Huh? Different answer you got. Sandra, how much you got? 3168. Angel, 3168. Sia, did not get. Last bit. Salim, how much you got? Still doing. Anika, Janice, Harni, Hussein, Rian, Ron, keep the cameras on, children. Gautam, Upika.
My camera is on, sir. So I got the answer.
All right. Ria, oh, Ria, you are there in the class. Sorry. Bhavesh, Aditya, Afnan. Ria, keep the camera on if you don't have any network issues. Huh? Harni, Gopika. Okay. Shall I help you? Now, listen to this. Listen to this. I gave you the radius of the cylinder. How much it was? The radius is equal to 21 centimeter. And I asked you to find only the distance covered by the cylinder. So if I'm asking you to find the distance covered by the cylinder or distance covered by a wheel, the formula should be the same, isn't it? What is the formula? 2 pi r. Because you know the distance of a cylinder or a wheel, it is equal to 2 pi r in one rotation. So let's find out in one rotation, how much is the distance covered? Children, in one rotation, the distance covered is 2 pi r, which is equal to 2 into 22 by 7 into radius is 21. 7 ones are 7 threes are. 2 into 22 is 44. 44 into 3 is 132 centimeters. Try to understand that the cylinder covered a distance of 132 centimeter in one rotation, isn't it? Now, in 1 second, the wheel undergoes through how many rotations? 4 rotations, isn't it? So, in 4 rotation, how much is the distance covered? It would be 4 times 132. Isn't it? 4 times 132, which is equal to 8, 12, 1, 9. How much? 528. So 528 centimeters. Makes sense? Now, children, how much time? For total, how much time did the wheel rotate? 6 seconds, isn't it? So here, in 4 rotations, that means in 1 second, that means 4 rotations. The distance covered is what? 528. Total, how many seconds it is traveling? 6 seconds. So in 6 seconds, the total distance covered would be 6 into 528. How much ever? 3000 plus 100 3168 centimeters. Got it, children? No, no man, centimeter. Distance, no? Distance is centimeters. Children, did you all follow it? This is the step-by-step way of solving the sum. Now, if you feel like solving this in one single step, you can do it. How you know? Children, the distance covered in one rotation is how much? 132 multiplied by the number of rotations in 1 second is 4. So you got 132 into 4, isn't it? Now, the total number of seconds for it traveled, how much it was? 6. So you just do 132 into 4 into 6. There also you will get the same answer, 3168 centimeters. Okay. The first one is very lengthy and the second one is very short. Am I clear with this? Maria, Janice, you all still have a doubt? No? Ria, no doubt? Okay, so this is all about the distance covered. Now, children, I have one more question related to this. One more question. Sachin, did you follow? Huh? Yeah. The question is, if this cylinder takes 6 rotations in 1 second, and the total time it rotated is 3 seconds. The total time it rotated is 3 seconds. Then find the area covered by this cylinder. The area covered by the cylinder. So please understand, in the first question, I asked you to find the distance. And in the second question, I have asked you to find the area covered by the cylinder. So I have taught you a very easy technique. Distance, 2 pi r. Area, what is it? 2 pi rh. Or you use that concept which I teach you. 19. You do it in the way you are comfortable, children. Forget about what I taught you. In the order.
So the radius and the height is same, no, sir? Like what you have mentioned.
Same.
Okay.
In 1 second, it can do 6 rotations, and the total time it traveled is 3 seconds. Use your own logic, children. Long method, short method, that does not matter. It's given over 21. And the height is 35 centimeters. Eight three. Okay. What about Jaren? Same answer. Nabil? How much? Are we done? Okay, many of them have answered 83160. Very good. Maria, Caitlin, Amal, good job. Janice. I think it is 83160. Yeah. So let's confirm the answer, huh? One last time. You need to spend so much of time, children. Otherwise, concepts will never get registered in your head, isn't it? You have to try, you have to fail. Then again, you will try out with the formulas and then you get the answer. Meanwhile, the concepts will get registered. Okay, now listen to this part. So this was the question asked. There is a cylinder, silence, silence. This was the question asked. If this cylinder is taking rotations, then how much would be the area covered, isn't it? How much is the area covered? So imagine this is the distance covered by the cylinder in whatever time they have specified. Okay. Children, so they are asking us to find this area. So you have understood when the cylinder is rotating on the ground, after rolling from one point to another point, the area which it covers, it looks in the rectangular format, isn't it? It looks in the rectangular format. And if you want to find the area covered, you just need to multiply the length covered multiplied by the breadth. Breadth is in fact what? The length of the cylinder itself. Now children, let's find out how much is the length covered by the cylinder. According to this data, how much is the length covered? So it is going to be 2 into 22 by 7 into, what was the radius here? 21 centimeters. What is 2 pi r? It is the distance covered in one rotation. Please keep this in mind. What is 2 pi r? It is the distance covered in one rotation. Likewise, how many rotations it is taking in 1 second? It is taking 6 rotations. And for total, how many seconds it is rotating? For 3. Isn't it the most easiest calculation to get the length of the distance covered by the cylinder? Let's simplify this. 7 ones are, 7 threes are. So you get 2 into 22 into 3 into 6 into 3. How much it would be? 44, 132. 132 into 6 is how much? How much ever? Can you just tell me what is the distance? 2376. Thank you so much. 2376 centimeter is the distance covered by the cylinder, isn't it? Now, if you want to find the area, that would be just L into B. What is the value of L? Just now you said 2376 multiplied by how much ever is the length of the cylinder. How much it was? 35. You multiply these two values, whatever is the answer, that is the area covered by the cylinder from point A to point B. Now I am clear with this. You need to understand what is the difference between finding the distance covered and the area covered. That is why we spend around half an hour for this. I hope you will not forget this. Children, if you still have a doubt, recorded session is there. Please do watch it. Okay. I don't think there is a need now. Understood, no, children? I can teach you more than this. Understood, everyone? Online students, Priya, Janice, everyone understood. No, Harini, Anika, Priyan, boys and girls, everyone, just tell me. Very good, children. Okay. So let's move on to the next sum. Okay, start doing. The school provides milk to the students daily in cylindrical glasses. No, in government schools, they used to provide before midday meal. Now also it is there. Are you the city collector? No, right? You're so concerned about milk for the school children. You solve this somewhere. The school is providing milk to the students daily in cylindrical glasses of diameter 7 centimeters. So, children, glass in the sense it's a hollow cylinder, right? Because you have to contain milk inside it. Yes? What, Joshua? You said something? The base is closed, yeah. So draw the glass in such a way that the base is closed. Tell me. Let me first read the question. I'll tell you. Wait. A school provides milk to the student daily in cylindrical glasses whose diameter is 7. So can you tell me how much is the radius? Wait, Alvin, what is the radius? Wait, what is the radius? What's the radius? How many is it? Radius of the rock. Radius of the rock. Yeah, let's continue. So how much would be the radius? The half of the diameter, that is equal to 3.5 centimeters, right? If the glass is filled with milk up to a height of 12 centimeter, if the glass is filled up to a height of 12 centimeter, let's imagine, children, this is 12 centimeter. Now, please don't ask me what is the height of the glass. Hurry, children, I don't know. It is not given to us, right? There is a glass with certain height. Now, it's a government program, so don't expect that the government is going to fill the entire glass with milk, right? Yeah. So the government is giving away milk to the children, making it a point that, you know, the height of the milk in the glass is up to 12 centimeters. All right. Now, they are asking you how many liters of milk is needed to serve 1,600 students. This is simply based on unitary method. You find out how much milk is given to one child, then multiply it with 1,600 students. Isn't it? Simple as that. So how, Alvin? Yeah. So how will you find the quantity of milk inside this? Pi r square h, isn't it? And children, they haven't mentioned about small r or capital R. So it is a matter of common sense to understand that they are talking about the inner radius of the cylinder. Nee glass in a portu nada palu idikine. Outer radius ne vendi. ഞാൻ നിന്റെ വീട്ടിലോട്ട് വരാം, നീ ഒന്ന് ഒഴിച്ച് കാണിക്കണേ ക്ലാസ്സിന്റെ പുറത്തൂടെ. തോന്നി മാസം അല്ല. Children, let's get back. So here the radius is 3.5 and the height up to which the milk is filled inside the container is what? 12 centimeter. Let's find out the volume of milk or the quantity of milk. Salim, are you following it? Huh? So how much will be the quantity of milk inside the glass? It is equal to pi r square h. Pi is what? 22 by 7 into r is what? 3.5. So 3.5 into 3.5 into its height, which is 12. Okay. Do it. 7 ones are 7 into 0.5. So 22 into 0.5 into 3.5 into 12. And you all know how to simplify numbers where decimal points are there. How do we do it? Just multiply the numerator and denominator with 10. Isn't it? Hello? Can't I write 0.5 as 5 by 10? Isn't it? Can't I write 3.5 as 35 by 10? Yes, multiplied by 12. So rather than, using decimal points, I think you can use fractions to solve. So 5 ones are 5 twos are, 2 ones are 2 11s are. Then 5 sevens are 5 twos are, 2 ones are 2 six are. So you're getting 11 into 1 into 7 into 6. And how much should be the answer? How much? 462 centimeter cube. This is the quantity of milk which one child gets, isn't it? This is the quantity of milk which one child gets. Any doubt, children, please ask. No? Alvin, did you follow it? This side, Monish, Milan, everyone, Salim, Freddy. Okay, so children, let's find out the quantity of milk. Let's find out the quantity of milk for 1,600 students. How much it would be? $462 multiplied by 1,600. And how much it is? Yes, Anika, we have found the volume, no, Anika? Volume
Yes,
is what? Centimeter cube. Yeah. Give me the final answer, everyone. 7392 000. How many zeros? Only 2 zeros are there. 7392 000. All right, all right. Caitlin, just check it once again.
Yes, sir. I put an extra zero by mistake.
Okay. Yes. I'll come to that point. I'll come to that point. Now what you have found in centimeter cube, right? Okay. Now I am going to teach you a very important concept, children. And the concept is converting centimeter cube into liters. Because if you notice, they have asked you to find the answer in liters. Right? They have asked you to find the answer in liters. So let's do it. Children, I'm going to teach you the technique of conversion here. Okay. Imagine you have a water tank in your house whose dimension is 1 meter by 1 meter by 1 meter. Just assume, children, you have a very big water tank whose dimension is 1 meter by 1 meter by 1 meter. Okay. In this water tank, whose volume is 1 meter cube, you know how many liters of water can be contained? Imagine you have a water tank in your house whose dimensions are 1 meter by 1 meter by 1 meter. Can you tell me how many liters of water can be contained in this? It is 1,000 liters. Okay, it is 1,000 liters. Can you please make a note of this? 1 meter cube is equal to 1,000 liters. Okay, note it down. Now, if I ask you, 1 meter is equal to how many centimeters? 1 meter is equal to 100 centimeters. So what is 1 meter cube, children? 1 meter cube means 1 meter into 1 meter into 1 meter. And that is equal to 1,000 liters, right? 1 meter is 100 centimeter into 100 centimeter into 100 centimeter, which is equal to 1,000 liters. You all agree with this? I'm just converting each of the 1 meters into what? 100 centimeters. So 100 into 100 into 100 is how much? 1 followed by how many zeros? 6 zeros. So 1 followed by 6 zeros, centimeter cube is equal to 1,000 liters. Please note it down, children, very helpful. 1 followed by 6 zeros, centimeter cube is what? 1,000 liters. Now, can't I cancel? Children, can't I cancel 3 zeros from both the sides? I can cancel 3 zeros from both the sides, right? So can't I say 1,000 centimeter cube is equal to 1 liter? 1,000 centimeter cube is equal to 1 liter. So if 1,000 centimeter cube is equal to 1 liter, can't I say 1 centimeter cube is equal to 1 by 1,000 liters? I can say this. 1 centimeter cube is equal to 1 by 1,000 liters. Can't I say 1 centimeter cube is equal to, and what is 1 upon 1,000? 1 upon 1,000 is 0.001 liters. This is how you get the value of 1 centimeter cube in liters. Okay, please redo the derivation at home also. Okay, because you will never get time to derive this during exam. In the exam, you have to by heart it. 1 meter cube is how many liters? 1,000. 1 meter cube is equal to how many liters? 1,000 liters. And 1 centimeter cube is equal to how many liters? 1 by 1,000 or 0.001 liters. Children, did you all follow this conversion? Huh? And at home, what you're going to do? You're going to redo the derivation of 1 centimeter cube is equal to 0.001 liters. Milan, stand up. What did I say? Repeat everything. Redo the what? Which thing? Derivation of what? In the what derivation? Okay, you look at me. 1 meter cube is equal to how many liters? 1,000 liters. And 1 centimeter cube is equal to 1 by 1,000 liters, which is equal to decimal value. Very good. Children, please go home and read over it. Okay? I mean, the derivation of this. Now, let's get back to the question. How much centimeter cube was the answer? 739,200 centimeter cube. They are asking us to convert this into what? Liters, isn't it? So children, you can convert this into liters by using 739,200 multiplied by 0.001 liters, isn't it? You are converting centimeter cube into liters. So you'll multiply whatever quantity you got with 0.001. How much it would be? 739.200 liters. Otherwise, you can simply write this as 739.2 liters. 739.2 liters. That is enough. Any doubt, children? Any doubt? Huh? Maria, Janice, no doubt. Ria, no doubt. Harini, Hussain, Rian, please tell me, children. Pavish, Gopika, Amal, Caitlin, Joel, no doubt. Ah, yes, Caitlin, you can divide it by 1,000. It's the same thing. Very good. Okay, the next sum. Hey, children, you have any doubt? No doubt. Sean, any doubt? No? Okay. The next sum. Yep. Draw the figure, everyone, and label the values. I'll do it for you later. Let me solve this one. Reading a novel. You're reading a novel. Is it a novel? Then show me a book. How many of you could solve this online? Harani, Anika, Hussein, Rian, keep the camera on.
Yes, sir, 160.
Oh. Very good, Maria. Pinchu, in the booklet already. Who else? Very yes, Maria. I think so. Done. Sia, solved? No. Priya, solved it? I don't know, Caitlin. I'll check her. Just a minute. Mila, നിനക്ക് സ്വന്തമായിട്ട് ചെയ്യാൻ പറ്റത്തില്ലേ? Salim, did you solve it? Loga, show me your book. I asked you to draw the figure, right? You draw this figure. You look at the figure, Anoki. What should be the length? All right. Who has solved it? Amal, Rian, very good. Caitlin, very good. Now, pin drop silence. Nabil, you want to go home early today? No, right? Pin drop silence. All right. Children, a rectangular tin foil of size 22 by 16 centimeter is wrapped around to form a cylinder of height 16 centimeter. Find the volume of the cylinder. All right. So they were initially talking about what? A rectangular tin foil, isn't it? So let this be the rectangular tin foil. Joanne, what is the length? It is 22 centimeters. What is the breadth? It is 16 centimeters. Okay, I'm just labeling it here. Now this rectangular tin foil has to be wrapped around to form a cylinder of height 16 centimeter. So imagine, children, this is the cylinder which you are going to form with the help of this tin foil. Okay, this is the cylindrical shape which you are going to generate with the help of this tin foil. And if you notice, the height of the cylinder is given to you 16 centimeters. The height of the cylinder is given to you as what? 16 centimeter. Children, there is something very important that you have to understand from this. What is it? You know, the breadth of the rectangle was how much? 16 centimeter. And the height of the cylinder is how much? The same 16 centimeter. So, you know, indirectly what they are trying to tell you, whatever was the breadth of the rectangular foil, that has to become the height of the cylinder. That has to become the height of the cylinder. So children, can't I say you have to wrap this tin foil along the length of this foil? Do you agree with this? Try to visualize it, children. Imagine this is your rectangular foil. Okay, imagine this is your rectangular foil where this is the breadth and this is the length. Okay, the longest portion is the length, shorter portion is breadth. Now, what are we going to do? We are going to wrap this tin foil in such a way that you generate a cylinder. And what is the height of the cylinder? It is equal to 16 centimeter. So children, you are wrapping this tin foil along its length, isn't it? You wrap this tin foil along its length so that the height of the resultant cylinder remains 16 centimeter. Can I say that? Children, in this figure, did you notice I have drawn arrow marks? I have drawn arrow marks to indicate that this tin foil was wrapped along the length 22 centimeters, so that the resultant cylinder's height remains 16 centimeter. Are you getting it, children? Imagine this is 22 and this is 16. Okay. Now, after wrapping the tin foil, if you need to keep the height of the cylinder as 16 centimeter, you should be wrapping this tin foil along the length of the tin foil, isn't it? See, the height of the cylinder is 16 centimeter. Okay. So children, if you have understood this concept, let's try to solve it. Now children, can you tell me what will be the circumference of this cylindrical shape? Can you tell me what will be the circumference of the cylindrical shape? It will be equal to the length of the tin foil, isn't it? Because you wrapped the tin foil along the length. So that length got converted into what? The circumference of the base and the top, isn't it? That means 2 pi r, which you say as the circumference of the base or the top, that is equivalent to the length of the aluminium foil. Was I clear in this? Yes? Maria, Janice, everyone? Huh? All right. So children, 2 into 22 by 7 into r is equal to 22. So Let's cancel 22 and 22. You get 2 by 7 into R is equal to what? 22. Oh, sorry. Is equal to 1, right? So R is equal to what? 7 by 2, and that is equal to 3.5 centimeters. You got the radius of the cylinder, children. You got the radius of the cylinder, 3.5 centimeter. Height is already given to you, 16 centimeter. Can we find what is the volume of the cylinder? Can we find it by using which formula? Pi r square h. Let's do it. So it is 22 by 7 into radius is what? 3.5. So 3.5 into 3.5 multiplied by its height, which is 16. Do the calculation, get me the answer. 600 and 616. Very good. 616 centimeter cube. Children, at times they can give you the same kind of question, but by using the sentence like this. If the cylinder is rolled or wrapped along the length, then what is the volume of the resultant cylinder? Okay, children, I will give you a question here. We have 5 more minutes to go. So let's solve this one additional question and then leave. Okay, I want to see who will do it first. Okay, be ready. This is my own question. There is a aluminium foil, okay? There is one aluminium foil whose length is 35 centimeters and whose breadth is 21 centimeters. I want you to find what would be the volume of a cylinder if the foil is rolled or wrapped along its breadth. Okay. Same question as we did now, but in a different way I have framed it. Okay, do it fast. So draw the figure, get an idea, children. Okay, along the breadth it is going to be rolled. So you have to determine what is going to be the radius of the circumference and also the height of the cylinder. Do it fast. And okay, you do your work. Show me, wrap it. Now what should be the height of the cylinder? What should be the radius of the cylinder? Fine. Got the idea? And okay, you show me. Online students, you can start answering me. Caitlin, just take a fraction. Take it in the fraction form. Okay, don't find the decimal value. Yeah. Roll it and show that. Along the breadth. Along the breadth. Who has given me the answer? Yeah. Maria, it's a very big decimal. Is this the final answer? Okay, fine. At least find it to one decimal place, Maria, without using a calculator. Anika, Harani, Hussein, Riyan, Gopika, Ron, Amal, Caitlin. Yeah, very good, Amal. Good job. Good job. Maria, did you follow everything what we learned today?
Like I joined only like when the second sem started, sir. I reached home late.
Okay, not a problem. But did you follow after that?
Yeah, like I was able to follow bit by bit.
Okay, fine. Not completely, no? Okay. So just watch the recordings, Priya, the first portion.
Yeah, sir.
Okay. Loka? Hold the screen. Hold the screen. Okay. All right. So let's just confirm the answer. It's very big. Decimals, yeah. Only in one decimal. Very good. Mama, Maria, Maria, Maria. Please roll the paper. Along with that, you have to roll the paper. Roll it along the way. All right. Let's check, huh, Caitlin? Caitlin, now please, last 5 minutes. When I ask you to fold or wrap this cylinder, sorry, this rectangular foil along its breadth. Children, you should understand, Acha, what was the length and breadth? 35 and 21, right? So this is 35 and this is what? 21. Children, how will you wrap this foil along its breadth? This way, right? Huh? This is the way you have to wrap it along the breadth. So what will happen? This will be the resultant cylinder which you are getting. This is the resultant cylinder which you are getting, where the length or the height of the cylinder will remain 35 centimeter and the circumference, children, the circumference of this cylinder will become what? 21 centimeter. Isn't it? Because you folded it along its breadth. So whatever was the breadth, that will become what? The circumference of the cylinder. Did you all follow it? Now, children, let's find out how much it would be. 2 into 22 by 7 into R is equal to 21. Now, R is equal to 21 into 7 divided by 22 into 2. how much it is going to be? 147 divided by 44. Children, please don't convert this into a decimal value as of now. Okay, leave it like that. Now, I had asked you to find the volume. What is the volume of the formula? Check. What is the formula of the volume? Alvin? Pi r square h. So this is equal to 22 by 7 into 147 by 44 into 147 by 44 into its height, which is 35. I know it's a very big calculation, children. Okay, that is just because I gave you random values, isn't it? If I had been very conscious about the calculation part, I would have given you some numbers which you could have easily eliminated. Okay, anyways, those who have applied this method, they should be getting the right answer. I'm not going to do the entire thing. I just wanted to show you the correct method. Did you all follow it? Along the length, along the breadth. Okay, fine, children. So that is enough for the day. If possible, I'll keep a class tomorrow evening, if possible. All right, because in my church, feast is going on, children, so I may have to go there. Okay, if I come back early, then I'll try to keep a 1 hour session. Joanne, what did I say now? What did I say now? Correct. Okay, so for today, this is enough. I will text you by tomorrow morning, children. Kindly wait for my text. Okay. Yeah. Children, whatever we did today, I want pin drop silence. Can't you see that I'm talking? Children, whatever we did today, is it clear in your head? I know we have done hardly 5 sums in 1.5 hour session, more than 1.5 hours. But I think this was productive, right? We learned a lot of things, how to find the distance, how to find the area covered. Then when the paper is rolled along the length, along the breadth. All these are concepts, children, which you need to learn by using illustrations. In school, just because of the shortage of time, they will just draw the figure, use the formula and solve it. Where you will learn how to do calculations, but you will never get any familiarity with the concepts, the background happenings of each and every sum. Okay, since we are getting more into that, we are consuming a lot of time. Kindly bear with me, children. But one thing I can assure you is you will never forget mensuration once we do it in our class. Okay, because no matter in whichever way they ask you the questions, in whichever way they want to twist and turn the questions, let them do. You will be able to solve it in the board exam. 100% guarantee I can give you. That's how we are going to deal with this chapter. Okay. Fine, children. Thank you so much for your patience, cooperation, everything, love, and care. See you very soon, children. God bless you all. Good night. Take care.
Thank you.
Bye.
Thank you, sir. Bye, sir.
Thank you,
Thank
sir.
you, sir.
Bye, children. Bye.